send the question to your instructor, and then I can go in and change it. All right, guys. Woo! Any questions on that thing I just handed out? Yes.
So the current average up top and the average with all turned in are two different numbers, or
yeah, they certainly are. So the one at the top is not including homework, as if homework wasn't a part of your grade. So it's just basically your quizzes and your test. At the bottom, I say what your average would be with all the homework turned in and good, or none of the homework turned in. So if you have half the homework turned in, you're halfway in the middle of those two numbers. You guys kind of with me? Yeah.
Can you pass me one back? I just want to.
Oh, I'll give you yours.
Oh, okay.
What's your name? Oh, Hannah.
You can have Brandon's persons. Very helpful.
Everybody else up there? So. There's Sean.
Yeah.
I got a couple sections to do.
All right. Yikes. Yeah. All right. How's that? Is that good? All right. So let's get back into it. I don't know what I'm doing. Make it. All right. So, any questions from homework first, real quick? Yes. So I saw you first.
Yeah. Can I get them? Number 10,
3-3.
Yeah.
And remind me, guys, what's happening on Monday? Or Tuesday? It's going to be a good week. Huh? No, Thursday's the test. I would never give you a quiz the day before. No, I'm going to make the. Let me say this. I'm going to make the test on Thursday instead of Wednesday. Yes.
Yay!
Yeah. That's better than quiz, test.
So we're doing this on Monday and Tuesday, and then
Cool. Sorry, so number 10, 3-3. Ooh, I like it. So, this is going to be a good review problem. You guys, I think your question is probably related to the form they want you to put it in, right?
No, like I was just trying to check if both was like long divisions. I wasn't getting the right same answer.
Okay, let's do this. So if I ask you to do this, there's something in there you got to be careful about. Yeah, so go ahead and synthetically divide this real quick. You missed yesterday, you're like, what did he just ask me to do? So maybe just sit there for a second. Let's make sure we're on the right track. Alright, so it should be done if you understand synthetic. And if you remember that 0, right? Why is that 0 there? No, it's squares. Good, I like it. So 1, 4. Why negative 4?
No, you add.
It's already, it's changed already.
Yeah, so remember, normally we'd have a -4 there when we long divide. So what synthetic division do that's so cool? Changes the sign in the first place. So then I'm adding instead of subtracting, which is almost better. So 4 times 4.
16. 88. 83.
Alright, so is that what you got?
yeah.
Is that what you got?
Yeah.
But, so long division didn't work out the same way?
That's a different
Probably
problem.
the X squared kind of like
Oh, okay.
And I wasn't putting the 0 in there at
Ah.
the beginning, and then I just got X squared plus 10 plus 45.
X squared plus 10
He didn't have the 0.
Oh, I see.
It was 0.
Oh, okay.
Another one, I was getting the 4x, and I was like, how that's problem?
Gotcha. All right, gotcha. So yeah, so what would this look like? This would say then, another way to say this is x cubed plus 6x minus 5 over x minus 4 equals what?
X squared plus 4x plus 22 plus 83 over x.
Now let me see if you guys can handle this next thing. All right, there's one little thing I haven't talked about yet from this section. It's called the remainder theorem. Sounds like magic when you first read through it, but let me see if you guys can. That's done, right? That's the answer to what that is. Now watch. Couldn't I multiply both sides by x minus 4?
Yeah.
No. Yes, you could. So then I'll get x cubed plus 6x minus 5 equals. Let me stop that. Let me make sure you guys agree with me. When you multiply it by x minus 4, you get that mess times x minus 4. And of course, that times x minus 4, the x minus 4's cancel, you get 83. So if this is my polynomial, we're calling this, we'll say that's p of x. What is p of 4? 83. And isn't that exactly what that is? Of course it is, right? So look what we divided by. 4. So if you have a polynomial, and if you have some ugly ass polynomial, x to the 7th minus 16, x to the 6th, blah blah, and they ask you what is p of negative 2, synthetically divide by negative 2, and the last number is your answer. That's the remainder theorem, right? It's called the remainder theorem because it's a theorem that relates to the remainder. What does the remainder actually tell you? Don't you like that? Math people are so creative. The remainder tells you something interesting. It actually tells you a value of the polynomial because of this. This piece dies at that number, so then the number that's left over is the answer. How's that? If you've been doing this homework, you might have hit something that says remainder theorem, and you're like, what the hell's that? Or some of you guys are like, I didn't have the problem because I haven't done the homework yet. Oh. Huh? Yeah, totally. So you can read about it. Yeah.
I totally blanked on number 7. I was trying to do synthetic division, and I know you have to do long division on it. Can you go over that one more time?
Oh, it says use either synthetic or long. So
And it has the x squared on the bottom, so
you can't do synthetic.
no.
No. You could, but you'd have to divide by plus or minus 3 rad 3I. Screw that shit. So watch it. If I'm dividing by x squared plus 3, how do I factor this? I like how it said, how do I factor it? How do I factor that? I love the look on your faces. Factor it. Do it.
Take out.
No take it out. There's no GCF. You can do it. Do it. So 2 things are wrong with me asking you to factor this, right? But you can still do it. You can still factor it. 2 things that are wrong because it's not what you're used to. It's a plus. You're not supposed to be able to factor sum of squares. Okay, I'll use complex numbers. That's one reason they exist. Because they multiply together and they make a negative, so they kind of, right? I squared is negative 1. And 3 is not a square, but what's the square root of 3? Square root of 3. Alright, so then I would factor this as x plus I rad 3, x minus I rad 3. Let me let that soak into your brain for a second. So you couldn't factor this back in Math 110 because you were back in Math 110. Now you know more shit. And actually, towards the end of Math 110, I actually showed them that. I mean, this is something you do. Once you learn complex numbers, you do this all day long. So you could synthetically divide by negative I root 3 and then I root 3 at one after the other, and that would be the same thing as dividing by x squared plus 3. Do you want to do that? No. No. So I would do long. It's not synthetic doesn't work here. It's just that it's irrationally difficult.
Not enough. Not worth it. I was actually asking, could you do it long division really fast?
Oh, okay.
Sorry.
All right, let's. So this problem, does it have any? Which one was it again?
7.
Yeah. So one thing to realize is it's missing a term, right?
It's missing its x squared. Yeah.
Bless you. Let's see. There it is. could do it without putting that in there, but then it gets kind of difficult to follow. And it kind of sucks that this is missing one, but you just line up your like terms as you go. So what do I mean by that? I don't know yet. Let's find out. So somebody start me off.
X squared.
Yeah, x squared goes in x4, x squared times. So when you multiply them, amazing enough, you get what we just said. X squared times 3 is?
3 squared.
Why would you put it there? Doesn't make any sense to put it there, of course, right? So two things. I love it when people put it here and then they force it to add. They're not like terms, right? Like terms never goes away. Here I have to do what? And the second thing is, don't forget that dude, just because nothing lined up underneath them, that means there's 0 here, right? So that effectively comes down. What's the result here? And then bring down the 4x, all right? And keep going. Is that, did you hit a problem spot yet or no? Is it?
I just forgot how to set it up, honestly, in the beginning, so I think it should be okay.
All right, cool. Continue in the same manner. I like that. Is that cool for everybody? Can you guys finish that one on your own? All right, good. I'll take it as a yes. Anything else from homework? No. Okay.
Remainder Theorem on 45, 50.
Yeah, let's look at 45. So 45 gives you this. This is still section 3.3. And they say what? And they say C equals -7. What they really mean is P of -7 equals what? Using the remainder theorem. So, dear God, if you get the answer by plugging -7 in, it's nice, but it's not what they asked for, right? So they want you to use the remainder theorem. So how would I set this up? Synthetically divide using the -7. And of course, then this would be 5, 30, -40, 36, 14. Nobody's missing, right? So that's awesome. If you know synthetic division, remainder theorem is really cool. It's just an interpretation of what that remainder means. At first, it just meant it's not 0. If it were 0, it would go in evenly. That's a way to factor it. But now we realize if it's not 0, it actually still is information, thank God. It actually tells me something that might be useful. Right? So then you just got to synthetically divide. 35, 35. Yeah, -5, 35. Man, that looks gross. And then you get 71. Ugh. Does that look alright? That might be what they want to have happen. Yep, that's exactly what they want to have happen. So 497, negative. And so you get -483. So then what's P of -7? Now, answer me this. It sounds like I live under a bridge or something. Tell me this. Was that easier than actually plugging a -7 in to do by hand? Don't give me calculator crap. Oh hell, that's a ton easier. -7 to the 4th times 5. No, I'm already over that. That got pretty ugly, but still, it was really easy to do. So that's the power of the remainder theorem. All right.
What problem was that?
45.
45. It's section 3.3. Cool. I like it. Some of you guys are already looking at the clock. I love that. I try not to take it personally.
Is that all there is to the remainder theorem?
Dude, that's it. That is it. That is almost too easy to believe. Okay, cool. So last time we did division, we talked about synthetic. We got a little bit, we did some Descartes stuff. Talked about flies on the ceiling. We did. So I want to finish out with something that's a little bit more generally useful. So Descartes is either really useful or it's not worth shit. That's kind of like the takeaway from that. So we don't use Descartes' rule a lot, but you're going to use it in here just so you show me that you know what it means. These other two are kind of related to the idea behind Descartes' rule of signs. And this is the idea of upper and lower bounds. Because can you guys imagine now what a problem's going to be like? We sort of hit it already in class. You make a list of possible roots. You use Descartes' rule of signs to eliminate some maybe, and then you start trying some, try some. So if I try 8 and I get not a 0 at the end, I know 8 doesn't work. But what this now tells me is maybe I can look at that and maybe it gives me more information beyond just it doesn't work. Right? So here's what this is all about. Let me take an example that actually gets me somewhere. So if they give me this here. Whoops. Right. Yep. So I want you to do two things for me. Synthetically divide by -3. And also synthetically divide by 2. So do each of those separate for that same polynomial. And just make sure everybody's on the right track. It's missing a term, right? So be careful. So they shouldn't work, right? And when I say work, I mean they shouldn't come out to be 0. So the remainder theorem says something, but we're going to go beyond remainder theorem. So if you do this, how does this look so far? Is this right? All right, thank you. Ooh. And then what do you get when you do this one?
1, 2, 1, 4, 3.
All right, just to cut to the chase, who is it?
1, 2, 1, 4, 3.
1, 2, 1, 4, 3. Let's try it again. 1, 2, 1, 4, 3 is right. 1, 2, 1, 4, 3. Blah, 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 blah. Right. Yeah, good. Maybe we should do it. Let's see. 1, 2, 2, 4, 1, 2, 4, 8, 3. Okay. Now, real quick, I want to focus on this one for a second because it's a little bit easier to see why this is true. Like we did earlier, I'm going to write what this equals. That equals what did I just divide by? 2. Factor wise. X minus 2. So that equals that times this. And what is this? What did it start off as? So what is this now? Good. It was a 4th power, so now that's 1 power down. So that's the next cube. Is everybody cool with that? That's how I interpret the answer. It's going to be 1 degree less because we're dividing by 1 degree. So it'll be x cubed plus 2x squared plus x plus 4. And then I got that plus 3 sitting out there. That's what we just did a minute ago, right? When we're talking about the remainder theorem, that's another way to write the results. For any value I plug into this that's greater than 2, what's true about the output? It's positive. Kick ass. Is there any way that a value greater than 2 can make this 0? So this is an upper bound. So if you have this long-ass list of possibilities, 1, 2, 4, 8, 10, 12, 16, 30. You could kill everything that's above 2. And you can kill 2 because 2 didn't work. I really want you to understand this. No number above 2 could possibly make this polynomial 0, right? Any number above 2 is going to make it positive. Let that sink in. Does that make sense what I just said? Why? Because if I plug in anything above 2, this is positive. These are all positive. And then I'm adding 3 just to even make it even more positive, right? You guys semi with me here? Therefore, 2 is an upper bound for the positive roots. Kind of kicks ass. Yes, sir?
What does it mean by upper bound? Because if you go above 2...
No. What we just found is that there are no numbers above 2 that could possibly be factors of that, could be related to factors of this. Because no numbers above 2 could possibly make this 0. Everything above 2 makes it positive, right? So again, if my list of possible roots, I know it's not this, but let's just give an ugly example. If my list of possible roots was just crazy, disgusting, and blah, 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 I can kill everything above 2 now, including 2, because 2 didn't work. That is unbelievably useful, right? And this actually comes up a lot more often than poor little Descartes' rule of science. If he works, he's powerful, he kills half of your damn list. But he doesn't work all the time. Poor little dude. But this damn thing happens a lot. In the middle of your testing your numbers out, you just pay attention to the result. You go, oh, it didn't work, but they're all positive. Sweet, that's an upper bound. Now, real quick word, it's got to be a positive thing. So an upper bound has to involve dividing by a positive number. You guys hear me? If you divide by a positive number here, and you get no sign changes, they're all positive. See how that's kind of related to Descartes' rule? Then there can't be any answers above that. Yes, ma'am?
So if there's one negative in our answer, that would be true.
Exactly. It wouldn't say shit. It would just say, that doesn't work. It could be anything else. You guys with me? So don't expect this to happen all the damn time, but it actually happens a decent amount of the time. Now, I want you to understand, the converse is not true. If that doesn't happen, it doesn't mean that a root exists above 2. If that was negative, all it says is, I can't say. It could still be an upper bound, it's just the math can't say. But this tells you, oh, it definitely is an upper bound, right? There's no number above 2 that would work. I can cut all those other numbers above 2 out of my list. Because remember, what's the suckiest part about this process is that list can get damn big. And it can have fractions in it. Check. Right? So it's really nice to have something that you have to do this anyway. And if you look at the results, oh, they're all positive. I can kill all the bigger numbers. Sweet. Same thing kind of happens here. And remember what Descartes' rule of science said here? Let me see if you guys are cool with this. Well, what would this be? This answer. What would it be? X cubed minus. What's 43 over x plus 3? Plus 3. So, what I want you to remember, what did Descartes say about like the negative? This is p of x related to that. This is times x plus 3, right? But what did Descartes' rule say about, I'm trying to get to the answer very quickly. If I put a negative x in, I can see how many possible negative roots there are, right? Stay with me now. Does that sound, we just did that yesterday. So if you weren't here yesterday, that's why you're looking at me like you weren't. If I throw a negative x in, what happens? Every other one becomes, well, negative in this case. So how many sign changes would there be in the whole thing? None. Right? But it's not exactly Descartes because we divided by something, but the result's actually kind of interesting. That's a lower bound now. There's nothing lower than negative 3 that will work because the result came out with no negative roots, and actually is interpreted as more negative. There's no more negative roots than negative 3. And negative 3 didn't even work. So again, on the other side, you can kill everything that's below negative 3. You can kill them all because that is a lower bound. So if you divide by a positive number and it comes out all positive, that's an upper bound. If you divide by a negative number and the result is alternating, that's the lower bound. Okay? Okay, so let's do
Can
this.
you say the negative one again?
If you divide by a negative number,
And the signs change?
and the signs are alternating, changing, continuously, right? Alternating, then that's a lower bound. There is no lower number. So if you have any lower numbers than this in your list, you can cross them out. You don't have to try them. And remember, that was our whole, we're like, please, dear God, give me a way to cut this list down. Right? Or there's a huge way to cut that list down. All right. I like that. You're all writing something. This is good. So let me shut up for a minute. I want you guys to do this based off of what we just talked about. It also uses line of the wall man's results. There's a 4D card. Turning over in his grave. I did so much work and they're remembering me for the stupid stuff.
Are we doing this?
It's up to you. You don't even have to be here anyway. But I would like it if you would try this out. You can work together. You can call me over if you need help. Reference your notes if you forgot about Descartes. Yeah, if it alternates after dividing by a negative, it's a lower bound.
It says how many sign changes there are in P of X. Do we pick a positive number, or are we just taking the P of X that's already given?
Just the P of X, yeah. Right. I didn't make this a fractional possibility yet.